Hello, hello, sports fans. It's time for the chain rule. Buckle up, buckle up. So we have a new type of function here, which we have not observed yet in derivatives. So this is actually a function, exponential, with a function inside. So a function inside a function. So let's write this as such. So it's y is f, exterior function, with an interior function g. So it's f with g plugged in. Now the g of x, the inside function, is obviously my 2x here. And my exterior function is going to be my f. I'm going to use a different variable. I'm going to go f of u is e to the u. Now you can check, and you should check, that when you plug g into f, you do indeed get the function we care about here. Okay, so how do we do a derivative of a function inside of a function? Well, this is called the chain rule. And I can write it down over here. F of g of x. When you prime that, what do you get? Well, you get f prime. Now slow down. Don't get too excited. F prime with g plugged in. And then you multiply by g prime of x. Okay, of course this can be proven using the limit definition of the derivative. Now let's see how we can apply this in our case down here. Perhaps before I do that, it may be useful to write this out in English. So I often find myself saying f prime with g plugged in, comma, pause, times g prime. Okay, that may be useful to you to help you remember this formula. Now let's apply it down here. So my y prime is going to follow this formula up here. So I'll just copy that out. Why don't I just do a copy pasta here? Beep, 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 beep. Copy, copy, copy. Oh dear, can't do it. Never mind. Got an overlay that's blocking me here. So y prime will be f prime with g plugged in times g prime of x. So I need a few things here. I need f prime. So here's my f. So f prime of u is going to be, well, just e to the u. That's the simplest derivative there. And g prime of x, looking here, is going to be just 2. Okay, so to find y prime, I'm going to use these 4 things and plug them in to this formula here. So I get f prime, which is my exponential function. But I want to have g plugged in for u here. So I'm taking my g and I'm plugging it in to my f prime there. And then I multiply by g prime of x, which is just 2. Okay, so there you have it. F prime with g plugged in times g prime of x. And this dot multiplication corresponds to this dot multiplication. Okay, let's try another one. So y is equal to a function inside of a function. So y prime will be, actually before I talk about y prime, let's just define the exterior and interior functions. So f of u is the power 7 function. U to the 7. G prime is the, oops, not G prime. Sorry, I had G prime here. It should be just G, not G prime. I want just G here. G of x is the inside function, x squared plus 1. So I'll go ahead and find f prime of u. So I'm going to need it in a second. That's 7u to the 6. And g prime of x will be 2x. And my y prime will be chain rule, f prime with g plugged in, times g prime of x. So f prime is 7u to the 6, so I got 7, and now I'm going to have g to the 6. Yeah, I'll put these dots in green just to indicate they're the same dot. Okay, so f prime with g plugged in is this guy, and then g prime is, well, I've already done it over here. 2x. And we typically take a step to put our power of 6 bracket last. Like so. Which reminds me, did I simplify upstairs? Oh, I didn't. So this guy up here, let's go back there. Typically, you put your constant in front of your exponential. So that's considered simplified. Okay, we have a common idea of what is simplified so we can communicate more clearly. So I will insist that you put your constants in front of your exponentials. Okay, one more example. Down here, so my outside function, f of u, is going to be u to the power of 4. My inside function, g, will be that polynomial. Go ahead and find f prime of u, which is 4u cubed. G prime of x will be 30x to the 5 plus 6x squared. I have a good habit. I see this guy and I say, oh, factor, factor, factor. What can I factor out? 6x squared can come out. 6x squared can come out, leaving me with 5x cubed plus 1, if I'm not mistaken. Yeah, that looks good. Okay, so I got my f, I got my g, I got my f prime, and I got my g prime. So let's plug them into the formula, which I'm gonna, you don't have to copy this formula out every time. I'm just doing so for your notes to be nice and complete. So what do we got? F prime with g plugged in. F prime with g plugged in. Plugged in for u, right? So this is going in for u here. And don't forget your cube there. So I got 4u cubed. Dot g prime of x. This guy. Oops, no, the factored version. Dot 6x squared, 5x cubed plus 1. How does that look? So we rearrange this. I'm going to put my 4 and my 6 together, getting 24. Usually polynomial out front. I'll put my brackets last. 5x cubed plus 1. 5x to the 6 plus 2x cubed cubed. So what do you think about that? Okay, I'm having a long awkward pause here because I'm looking at my answer and I'm not quite getting what I want. Well, what is the issue? The issue is the answer is a even more simplified version. So just for kicks, let's see what we can do here. So what they're doing, or what I'm doing, or I did in the past when I made these solutions, is I'm looking at this guy and saying I can factor out x cubed. So factor out x cubed out here. And what do you get? You get 24 x squared, blah, 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 blah. And then we get x cubed coming out. 5x cubed plus 2. And that's still cubed. And now what we get is a 3 times 3, giving me 9. So I got x to the 9 here. Oops, let's go green here. I got x to the power of 9 happening here, which is going to multiply x squared and give me x to the 11. And voila. Okay, that's the nice simplified version. But to be honest, I would certainly accept this version down here. Okay, one last thing for this video. We want to remember Leibniz notation. So here it is. This is the chain rule in Leibniz notation. So in Leibniz notation, the chain rule takes this form. So where you have y is a function of u. So y is a function of u, and then u is a function of x. So you have a function inside a function, and the derivative takes this form. So this is like this guy corresponds to f prime with g plugged in, and this guy corresponds to g prime of x in our other version.